Welcome everyone. This is our second.
Sanjay, you went on mute.
Thank you. Good evening, everyone. Thank you for coming by. It's evening for me here. It's probably morning somewhere where you guys are. Francesco, it's afternoon for you. Thank you for agreeing to do this. We are really excited. This is our second DVA webinar, and Francesco has created something called a Unified Star-Schema, and he's written a book on it with the father of data warehousing, Bill Inman, and we're really excited to have him walk us through this interesting new way of building information marts. And we are grateful that he has agreed to attend. He's also going to be speaking at WWDVC, so you're going to be seeing him again if you're attending WWDVC. So Francesco, take it away. Floor is yours. Thank you again.
Thank you. Thank you. Hi, everyone. Welcome here. I see a lot of people. I'm scrolling. I'm seeing a lot of friends. And it's really good that you guys are all here. It's a beautiful day for me to be here. Also because this will be recorded. Actually, Sanjay, I hope you have started the YouTube. So it will be recorded on YouTube and it will remain online. And I hope that is going to be a video that people will watch also in the future, because it's many times I have people asking me if I have material about the Unified Star-Schema, and of course there is the book, but not everyone is able to buy a book or to find the time to read a book. So sometimes they would like to have a quick reference. So here it is, a video of 1 hour, or it can be a bit more, who knows, where I share all the key concepts. Okay, so I guess I'll kick it off. So this is my first slide. So it's building a data vault to information mart based on the Unified Star-Schema. You have to know that the Unified Star-Schema is a concept that is more general, but there are very good reasons why I'm happy to share it here at the Data Vault event, and that will come in the next slide. So very quickly about myself, I'm a consultant in business intelligence since 2001, and I've started with business objects, which now is SAP business objects, and then in general with SQL language, and then I wanted to go deeper into the data source, because when I was doing reports in business object, I was seeing that something wasn't really adding up. There was something that didn't make much sense to me. So I wanted to understand why it was like that. So I went to work in the data warehousing, and at some point I joined Teradata, which is of course a leader in data warehousing. Because I wanted to understand how data warehouse is done. And then I continued my reporting career with Qlik and Tableau. So I'm a very big fan of Qlik. I never worked for Qlik as a company. I simply love the product. And the Tableau is a super classic, and other products I've used also in other projects. And then I'm thinking now to move a bit to Python and R and other languages, because I feel a bit narrow in the world of BI tools. I want more capabilities, and I'm seeing that BI tools tend to give too much attention to the visualization, the color, how fancy is a chart. Well, I'm really a fan of numbers, and I'm a fan of like putting hands on data and fixing the data. So I see that in BI tools, there's a bit of a limitation, and I want to do more. That's why I prefer languages. So why Data Vault? Why am I here today? Who am I? Why am I a speaker at the Data Vault event? I'm just certified in Data Vault. I'm a practitioner, certified 2.0. I cannot call myself an expert of Data Vault. My story with Data Vault started when I basically got contacted by the marketing of Scale Free. So Mr. Jürgen called me and he said, there is a thing that should be interesting for you. And I said, I'll get back to you. And I Googled it and I said, wow, that looks cool. I mean, I was attracted by a few things. I can mention one, that Data Vault captures data as it is, with no bias. And it's a thing I like a lot, because when I was working for Teradata, for example, I saw that there was a lot of transformation and loss of data. And if there is one thing that you can say for sure about Data Vault, is that there is no loss of data. So I love that, as opposed to the approach of Kimbo, for example, which tends to be too much focused on business requirements from the beginning. So I simply like Data Vault, and I am being invited to these events. And I'm saying, wow, yes, great. And that's why I'm here today. Okay, so I'll start by a thing that happened to me a few days ago, actually a week ago. I got a notification on LinkedIn. There was an article that was saying StarSchema or single table. And this is a very old debate, which is coming every day. Every day I read something about this. And it starts like this. There are multiple reasons why a single large table is not better than a StarSchema. Here, in a way, the focus is strictly on performance. And then they go on, and the article is very long. But then I thought I would start my speech today about this, because I hear so much speaking about performance. And I wanted to know, first of all, like if you can quickly, I'm not very good at reading the chat very quickly, but what do you think, what is your opinion about StarSchema versus flat table? Do you guys think that one is better than the other, and why? So if you want to share this in the chat, I will have a look on my second monitor. So feel free. Be aware that I tend to be very interactive, and also you can, if you have a question while I'm speaking, I'm very happy if we are able to speak interactively. StarSchema, more flexibility. Yeah, that's one of the answers. So if you guys put the answers there, I hope I will read them at some point later. But yes, I definitely prefer a StarSchema, and the reason why I prefer it is not about performance. So most discussions about this topic are centered on performance, and today is different. I will talk not about performance, but I will talk about principles. Performance is important, don't get me wrong, but principles are more important. So this is, in many presentations, I'm showing this schema of AdventureWorks. It's a test database from Microsoft. And I like to show it as an example because everyone has access to it. So it's a sort of a referring point in the industry. So there are all these tables connected. Well, that makes me feel like, makes us feel very smart. So the question is, can we fit this entire database into one single table? So I'm checking now a bit of answers. In a flattened table, you can only provide the supposed view of the master data. Okay, someone says no, you cannot put this database in a flat table. That makes sense to me. No SQL, the performance. Yeah, I cannot go on reading messages, otherwise I don't focus on the speech. But yeah, I'm always very curious about this. And then I say, okay, fine, this database AdventureWorks is big, but what about this one? This database has only 3,000 rows and it's very small. So can we join all the tables in one single table or in one single view? Why can we or can we not do it? So again, here I will not manage to read the answer. But the example I brought today to you is made of 4 tables. Why did I do this? Because I believe that with 4 tables, I can share a lot of concepts. And it's quite funny that some time ago, one of the reviews of the book on Amazon, the reviews are very, very positive. But one of them was criticizing that I'm making examples that are too small. So the guy who wrote the review wanted to see like an example with 1 billion rows. And I'm totally the opposite, because I'm saying if there are problems already with less than 20 rows, we should better solve these problems in a small data set. And then we should address the problem of the performance, which is also very important. So let's remember one thing. what is the definition of correct numbers? So sometimes once I had a discussion with a friend of mine, Italian from Teradata, and he said, it doesn't matter, Francesco, numbers in any case are always wrong. Okay, fine, but we cannot start with this attitude. So to me, a number in a project of business intelligence is correct when it matches the data source. So for example, here, if this table is order details, so imagine that there are 4 orders, and it's very simple. So one client is ordering 100 units of this product, and then it's ordering 100 units of this other product. Then another client orders 100 units, but probably they are not fully in stock. And then another is ordering 100 units. So basically, when you watch this table in a report, you want to see 400. So 400 is correct, and another number is not correct. And this is very, very, very important. And of course, there are also the shipments. So the shipments are ideally happening all at once. Like this client had made this order, and the order was fulfilled immediately, 100 pieces. Same thing with the second order, it was fulfilled. But then the third one, 100 pieces, only 90 were sent. And then the fourth one, 100 pieces. Well, this is 70 and 30. So this is an example where there are 2 shipments for the same order. You see it here, order number 4. You have shipment 4 and shipment 5. So please remember these 2 numbers, 400 and 390. These are the numbers that we expect to see in a report. And also look at this, 3 million. It's the turnover of the customer, of the client. It's also another number that we want to show that we don't show incorrect. So I'm starting immediately with a live demo. As you know, as you might know, I'm very much hands-on. So this slide that I've shown to you, I've shown it from an example that is here in its original form. It's an Excel sheet. So the same tables that you were seeing on the slide are here. Of course, there's not much focus here on clients and products. Okay. The thing that matters is order details and shipments. Why does it matter? You will see it in a minute. So if I take my BI tool, Tableau, and I want to load these 2 tables in a report, I can do it very quickly. I go to my data source, original, and I can pull the order details, and then I can pull the shipments, and I need to tell Tableau that the shipment order detail ID is matching with the order detail ID. And then I can pull, if I want, also information about the clients. And again, I need to tell Tableau client ID goes with client ID. And finally, I can take the one of the products. And again, I will have to say Tableau product ID goes with product ID. This is a simple report, and we expect it to be correct. So if we go now to the visualization of Tableau, we can go, for example, to see the order ID. So I go to order detail ID, and then I want to show probably the product name and the client name. Maybe we reverse the order. And then especially I want to see the numbers that I was mentioning to you before. So I want to see the order quantity. So it will be in orders and the shipment quantity. Okay, and I want to see the totals. So 390 and 400. These are the 2 numbers that we have seen in the slides. So the numbers are correct. So you're saying, wow, okay, so there's no challenge here. But wait a minute. If I am also adding the shipment ID, for example, you will see here that there is something that is interesting, and it is still correct. And I'm saying now Tableau, it was not able to do this. They have introduced this functionality in January 2020, and I wrote an article about it because it's very cool. Look at this. You see the total 400, but the number here, 100, is repeated 5 times. So, of course, if Tableau was doing the sum of the numbers that are displayed, it would show 500, and 500 would not be correct. So why is this 400? Well, this is an important thing that many people do not know. The BI tools, if they pull all the data all in one table, they may have problems. but this problem is solved in this case because you see these tables, they are loaded in memory separately. So Tableau is able to say, okay, I see that I'm displaying 5 times 100, but the total is still 400. And Tableau says, I know it because I see the table at the original granularity, at the original grain, and I know that the sum of these numbers, despite the appearance, is 400, which is correct. Now, I go back to the slides because I want to make a point. I want to make a point. The point is that in Tableau, I see the correct numbers and I'm happy. The totals are correct, what I told you before, because they disregard the double counts. They are based on the granularity that was loaded in memory, loaded in separate tables. Please remember this, separate table. But some BI tools don't do this. And in any case, data science does not use BI tools. So data science, if you need to prepare, for example, a machine learning model, and you do the preparation for this machine learning model, well, you are a data scientist, you go with your SQL or probably with your R or Python, and you go to look for the tables, you save them into data frames in your environment, and then you do your operation. Well, you don't go through the BI tools. So this magic that you see here, that the numbers are repeated, but the total is still correct, this magic, you will not observe it in a machine learning data model. Because the machine learning data model, at the end, it will be one table. So the point that I'm making in the book is that denormalization is good, probably. But when you are denormalizing some tables in a way that they produce duplicates, sometimes you may have troubles. So let me show you what happens with the denormalization that you would do with these tables. You would have the shipments. So it would say the numbers that we had before. So the total, if you see it here in the bottom, is 390, which is correct. But then you would have these numbers repeated, and the total would be 500. So we have a problem here, because if you prepare the data, the famous data prep, so if you prepare the data for a machine learning data model, you will not have the correct total. So your order retail quantity will appear to be 500, and there's no way out. This is a problem that needs to be addressed, and that's why I'm sharing with you today. So I don't do it now in Tableau because it would take too long. I've done it earlier, so we can go on with the slides. So if you do it in Tableau now, the number that you will see will be 500 instead of 400. This one will be correct. It will be still 390 because there are no duplicates. And then, by the way, also the client turnover, it will become 5 million, which is instead the correct one is 3 million. So the totals now are incorrect because numbers are repeated, and the BI tool does not know the native granularity. So basically, if you take that data set I showed you in Excel and you load it into Tableau and you say to Tableau, show me the sum, Tableau is receiving 5 rows. Each row has 100. And Tableau says, listen, the sum of these numbers is 500. That's all I can do for you. And the same thing is happening in your machine learning model. So this is a problem. Denormalization, I want to conclude this way, that this data set must be avoided. So that's why I started this presentation of today with this article that I read last week, because yeah, everyone talks about performance, but here we are talking about 20 rows. Nevertheless, you cannot denormalize, because if you do it, you will have duplicates. You will have a fun trap. So what the hell is a fun trap? Well, the fun trap is a funny thing because if you search it on internet, you will find always different definitions. So there is not a standard definition of fun trap. And all the definitions that I see on the internet, they are somehow bad. I don't like them because fun trap is defined in a way that is too complicated. So people are saying, oh yeah, I heard about it. Yeah, sort of, it rings the bell. But no, you should notice that fun traps are happening in your data. So as they happen here in this data set, which is less than 20 rows, they will appear in the data of your client. They will appear in the data of your company. So I wrote this book because I wanted to make clear one concept. Some combinations of tables cannot be joined together, and you need to know it in advance. So what is happening today? People are joining table, and then they watch what's happening. But no, you already know it in advance. If you draw the schema in a nice way, tidy, you immediately see that some joins are forbidden. There's no point to make the join and test them if you already know in advance that the result will be incorrect. So here's the principle. Fund traps are actually not a problem of software. Again, many people are thinking, okay, with Power BI, I'll fix it this way, with Tableau, I'll fix it this other way. It's not about software or technology or a programming language. It's not about Excel, SQL, or the tools of BI, except tools of BI have a smart solution, but it does not solve the problem in general. They are not a problem in general of IT. Fund traps are a logical problem, and it is that some particular combinations of tables cannot be joined together. And if you take pen and paper, you will see the same. If you try to draw a table where you fit this sales and shipments, you will not really find a way to adjust the numbers, adjust the things, because a table needs to be rectangular. So somehow you need to handle the fact that one table has 4 rows and another table has 5 rows. So what is happening today in the industry? How do we solve this problem? Well, typically, when we have a report to do, for example, we want to see the fulfillment rate. So is it 100% or 90%? So you can do that by preparing the data based on a business requirement. And this is the thing that I want to change. So let's open, for example, if you have a client that is saying, you know what, I would like to see the fulfillment rate by order. Okay, so you have 100, 100, 90, and 100. Remember, this one was 70 and 30. But you cannot afford to have the 2 rows that you really have in the shipments, because if you do, you will have that famous duplicate we had before. So you have somehow to lose some information. It was 70 and 30. They were happening in 2 different dates. Probably the shipment type was different. That information here is lost. So you have a table that allows you to calculate. So you will have 100% here, 100% here, and 90% here, and 100% here. You can do it, but you have lost information. You still have it in the original tables. Yes, but in this one, you have lost that information. So again, we go on. So again, this is the report that you would do from the data source that I've shown you right now. So it looks good. Yeah, the final result is 97.5%. It all looks good. Everything is correct, but we had to create a new query. So a new query or a new data set, doesn't matter if you want to make it physical or virtual, but it's a new query somehow, and it's ad hoc. What is ad hoc? It means that someone said, I need to see this, and you need to ask a developer to sit down, write some code, and develop this solution. It's simple, but of course, it's happening also with less simple solutions. The problem is not about the storage on disk. It's not that now the storage on disk is cheap. So you can put a lot of gigabytes of data. We have Ken Tiraziano in this phone call, in this call. So of course, he will say, it's not a problem. You give us more money and we store all that we want. But it's not about that. The problem is that it's difficult to find the things. It's like you have a room full of toys, and then anymore you don't find anymore your Legos and your Playmobil. You have too much stuff. So the problem here is that reports create confusion because there is a loss of information. So it needs additional reports every time that you need some more need. So the report that I showed you, fine, you can see the ratio. But if you say, but this 100, was it happening in 1 shipment or 2 shipments or 3 shipments? When were they? Who was the responsible for the shipment? You don't have this information here. So you need to create another report where you are giving the detail of the shipments, but that report cannot have the comparison with the orders, because otherwise you have that duplication, which gives you a 500 instead of a 400. So somehow it's a cover that you pull it according to your need, but you're always having some side effect, and that's bad. And especially, last but not least, the produced reports are not integrated. So whenever you create this, and then you create another, let's say, Tableau report, when you say, okay, I want to see for each order detail all the shipments in their detail, yeah, that's fine. But they are two separate reports. So Tableau cannot read from another report of Tableau. So they are not integrated. And you know what happens at the end? It happens that people are watching one, they're watching the other, they want to make sense out of them. So what do? They export to Excel one, they export to Excel the other, and then they create the integration in Excel, in a spreadsheet in general. Why is that? Because we do not give them a possibility to have everything in one report. And why is that? Because it's difficult to integrate data, even when it's 20 rows. It's not 20 million or 20 billion, it's 20 rows, but it's already difficult. I just drink. I don't know if I'm speaking a lot. I don't even know if I'm still online. Do you imagine? Maybe I've lost my connection to internet. Is anyone there? Like Sanjay, am I still
online?
Fine.
You're going fine, Francesco.
Molto bene. Good. I would love to read all the chat and everything. It's impossible. I've already done it before. I was speaking and then I was confused a bit there, a bit here. So I will read everything later, I hope. So, fine. Yeah, this image, you have seen it a million times, I guess. These are the famous silos. So there is this sort of a figurative thing of data like silos, which is of course a bad thing. So data warehouse has solved this problem. So data was in applications, and thanks to the data warehouse, everything goes to one place where everything is integrated. So the problem is solved, except that it's not solved, because in the moment when you go to deliver data to the end users, because it's impossible to put everything in one table, as you guys said earlier, then you have to create different reports where you get different portions of your data. So you have solved the problem of the silos upstream, but then downstream, you still have silos. At the end, the only way to integrate data is with the spreadsheets. So silos are still a problem today, despite all the efforts created by the data warehouse. And when I wrote the book with Bill Inman, let me tell you this story. How do I know Bill Inman, first of all? I was studying Bill Inman at the university, and then suddenly I wrote a book with him. How did it happen? Well, the trick is that I saw that he wrote the foreword of the book of Dan Lindstedt of the Data Vault, and I said, wow, Bill Inman is still active on the market. So I searched him on LinkedIn, and I said, hey, Mr. Bill Inman, hi, I'm a fun Italian. You're the father of data warehouse. I wanted to tell you that the data warehouse today is a big mess. And he said, yes, Francesco, I agree with you. Let's write a book. And honestly, that's really the way it went. Because if there's one thing that Bill was really happy about my notes that I sent to him via email, is that I wrote to him, there are too many reports, there are too many data marts. And he said, exactly, it's a mess, let's solve it. And I said, you know what, Mr. Bill Inman, I have an idea. I have a solution that probably can eliminate the problem of having these silos in the reports. You can put everything in a StarSchema. And he said, come to the US immediately and let's speak. So I went to America and I spoke with him, and then we wrote the book. That's how the story went. So the question is, where did we go wrong? So if you think about it, business intelligence is deterministic. We are not making a prediction of future sales or something. It's deterministic. Data is given to us. More than this, data, the word data actually means given. So I went to make a photo. I actually asked my uncle a month ago to take a photo of a dictionary of Latin, because for Italians it's obvious, but for you it may not be, because data comes from the verb dare, which is Latin and it's also Italian, and the past of dare is datum. So data literally means the things that are given. So why do I say this? because I feel crazy when I'm speaking with my mother and I tell her my job is to give data to my clients, and she says, okay, and where do you take that data? And I said, well, actually, they give it to me. And then she says, well, and do they even pay you for this? I mean, you go to a company and you bring them data that actually they already have. Where did we go wrong? How is it possible that the majority of business intelligence projects produce incorrect numbers knowing that data is given? How can you fail it? The answer is that it's all about principles. So I wanted to introduce this guy. This is Euclid. Okay, now I really want to check the chat. So Euclid is the father of what? Do you guys know this name, Euclid? I guess you should. I want to check the chat if there's geometry. Mark Forlier. Okay, thank you. Yeah, Euclid is the father of geometry. More than this, he's the father of plane geometry. Well, actually, then plane geometry was extended to 3 dimensions and then also to n dimensions. So, for example, it's very common to calculate the Euclidean distance based on 15 dimensions. That's very common. But it's not the father of all geometry. So in plane geometry, everything starts with 5 postulates, which are called axioms or postulates. And these are the postulates. I'm not going to read all of them, but I want to read first. A straight line may be drawn from any one point to any other point. And given 2 distinct points, there is a unique line that passes through them. Okay, this is one of the postulates, and then there are others. Why am I showing this to you? Because starting from these postulates, it is possible to prove many theorems using deductive reasoning. So basically, what is deducting? You have to accept this. So if you don't accept the postulates, then we cannot do anything for you. But in the moment when you say, yes, I agree that a straight line, yeah, I agree to 2 points, yeah, I tried, there is only one way, like only one straight line that goes through 2 points. Okay, I accept them, fine. Starting from that, if you accept all of the 5, now I put only 4, if you accept all of the 5, then all the other things are deductive reasoning. So there are proofs that are arguments that are saying, if you accept these 5, as a consequence, necessarily, there are other proofs that can be delivered. And one of them, we all know, the Pythagoras theorem. Okay, the Pythagoras theorem is valid when the Euclid's 5 postulates are valid. Okay, so this is the formula that we all know. But if even just one of the 5 postulates is not true, then also the Pythagoras theorem is no longer true. Again, is there an example, guys, that you can give me where, back in high school, where the theorem of Pythagoras, well, the 5 axioms of Euclides are not true? So do you have an example where Euclides doesn't apply? On a sphere. Borna, my friend Borna. Yes, so it's exactly on a sphere. So on a sphere, the Pythagoras theorem is like that. Cosinus A, cosinus B equals cosinus T. I must be honest, I learned this thing yesterday. I was Googling that. I knew that it doesn't apply, but I didn't know the formula. So what do we say then about Euclid? I mean, there's no blame on him. So basically, this formula is an extension of the work done by Euclid. Euclid is a good man, but then there are more things to do, okay? Okay, talking about principles, who is the fastest to tell me who is this man? Geometry, okay. So who is this man here? Let's see who is the fastest to reply. Ralph Kimbo. Thanks, my friend Mark. So this is Ralph Kimbo. He's the father of Mark. You can say also this one. The stage is yours. He's the father of. In the meantime, I can drink. Dimensional modeling. Thank you, Mark. So he's the father of dimensional modeling. Here it is. A star schema with a fact table in the middle and all the dimensions all around. Wonderful. Dimensional modeling makes a series of initial assumptions. Now, I think you're understanding where I'm going with this parallelism. So, based on these assumptions, various methods are indicated as a solution for various data analytics requirements. Let's see. Kimbo published the Manifesto in 1997, dimensional modeling, right? I have put the link here. It's available on the website of the Kimbo group. And I have summarized because it's a long text, but I have summarized a few assumptions that are made in an explicit or implicit way. First assumption, tables are classified as facts and dimensions. Yeah, fine. Second, measures reside in the fact tables. So this is the retail sales, and the numbers that express a measure of the business are here in the central table. Assumption number 3, fact tables reference dimension tables. So you see all these FK, these foreign keys. So for example, the product key, you saw it in my example earlier, the product key is a code that you find in the product dimension, and it will tell you the product name, the unit price, and so on. And assumption number 4, each row of a fact table, listen to me, is uniquely identified by the combination of the foreign keys. Then there are other assumptions, but I have chosen these 4 because these are sort of the foundation of the dimensional modeling. Numbers are in the fact tables, and then we do a star schema, and then of course then there is the topic of conform dimensions. So you may have the same dimension to serve also fact tables. There's a bus of fact tables, all beautiful dimensional modeling, fine. But what if a table is neither a fact nor a dimension? I have asked this question a few times to my friends. You know, it happens to me to speak with friends about these things quite a lot, even too much. And the answer sometimes is yes, but when a table is neither a fact nor a dimension, it's not interesting for the reports. Says who? What if a measure appears in a dimension table? This, I love it. When I ask this question, people are saying it should not. The data source is wrong. The data source is never wrong. I mean, it's not like you go to the hairdresser and the hairdresser says, you know what, I don't cut your hair because your hair is wrong. What? So measures do appear in dimension tables. That's simply happening. What if a fact reference, if a fact table references another fact table? This is happening in every database. I have it here in this example I showed to you. If there is an order and then a shipment, well, the row of shipment wants to have a code of the order that has generated that shipment. And this for Kimbo is not interesting. What if the combination of foreign keys is not unique? And I guess that there are many people in this moment behind the screen who are saying, because it's happening every time. Imagine, okay, you don't need to be, I have here in the audience also people who are not from the job, but listen, this is a retail sales fact. Okay, you can't read it, it's probably too small, but it basically says that on a certain date, a customer went to some store and he bought a product, they bought some product with some clerk, okay? Fine, and with some promotion, okay. So these are the combinations of foreign keys. But wait a minute, if I go there and I say, you know, I want to buy 2 of these things, and then, okay, the clerk is pressing the button and is generating the bill. That has generated 1 row in your database. And I say, oh, no, wait a minute. You know what? The price is very good. I take 1 more. Done. So this is already a violation of one of the main assumptions of Kimbo. It's very common that the combination of the foreign keys is not unique. So I know what you guys are thinking. Okay, but if instead of the date, you put the timestamp with also the minutes and the seconds, it becomes unique. Yes, but I'll be talking about that in a minute. Well, I can even say it now. If you do that, it's fine. but it's not anymore a foreign key. So the date here, the date has references one row of the where is data mentioned. This one, I'm sorry that it's so small, but you don't have a timestamp dimension. So the timestamp is not a foreign key. So somewhere something doesn't add up, and that's not even the biggest problem, because okay, now this is zoomed a bit better. So I should have gone here before. Look at this. You have the foreign keys, okay, but then imagine. First of all, you can have here stock amount in a dimension. So that would be a violation of this assumption. Measures reside in the fact tables. Yeah, but here you have stock amount. You can't judge the data source. You cannot say that it's wrong. And so that's already a problem. Plus here, imagine you have the table of returns. So the table returns needs to be connected to the sales or the orders, whatever it is. So it needs to have the key, a foreign key that says, okay, this particular return is related to that particular row of sales, as I had it in the example that I showed you earlier. But is it easier that a retail sales row has a unique identifier, or you should combine the keys? Because to me, this thing of combining the keys is very painful. You should bring all these keys also in the returns table. And what happens if you don't do it, or if something goes wrong? It's much easier if you put directly a unique identifier for a transaction. And Stephanie is saying, aren't you mixing now OLTP model with the dimensional model? Yes, I am. Yes, I am, because I'm arguing, I'm questioning the dimensional modeling. Yeah, so I am mixing them exactly because in dimensional modeling, Kimbo has chosen to disregard some information which does exist in the OLTP modeling. So I am questioning if Kimbo had a good idea, because let me tell you, if your OLTP model transactional gives you the ID that references a row of your sales, that's given. You remember the photo of the dictionary of Latin, it's given. So why do we choose to lose it? Because it's important. Kimbo says that it's not, but my clients disagree with Kimbo. My clients, they want to see a report where they say for each sales, for each order or sales, call it as you want, how many returns did I have? Well, you cannot do it. Yes, you can do it now. Kimbo then introduces a thing called the key, some foreign keys that are called the generate keys, but they are not foreign keys, and it becomes all tricky. So somehow this thing of not accepting that fact tables are connected to each other by nature is the reason why, in my opinion, I'm sorry I have to say it, dimensional modeling is a weak solution. Okay, so if even just one of the Kimbo's assumptions is not true, then the dimensional modeling cannot be used. That's the point. And what are the alternatives to Kimbo? Well, you can have a data warehouse with Kimbo, the Inman approach, the data vault, anchor modeling. You can have a data lake house, an API, a set of APIs. You can have a lot of sources, not only in the data warehouse. But in the data warehouse, what is happening that the data mart, if it's Kimbo approach, is Kimbo. If it's Inman approach, this is still Kimbo. The data vault is using its own proprietary way of delivering data to the end users. But when it comes to the BI tools, the data vault is forced to use the dimensional modeling, because in Tableau it's very difficult to make a query when the data is organized in hub and spoke. So basically, everything is using either Kimbo or ad hoc, meaning that yes, you want to make a query on the data vault in the structure of hub and spoke, you write code, complex code in SQL, and you manage it. So what is existing today, to my knowledge, in the market, I'm checking if someone is writing something in the chat, is either the dimensional modeling of Kimbo or the ad hoc. Yes, doesn't it all say that there are no rules for the information layer? Yeah, do what business wants. Yes, exactly. But the business basically they want the star schemas of Kimbo because that's the only thing that they are used to. So you can do what you want, exactly. But what I'm saying is that whatever you do, it's either Kimbo or ad hoc. There is not a discipline that is structured, pattern-based, repeatable, and that is not Kimbo. I'm not aware of any yet. So yeah, basically these are the two options, to my knowledge. But you can write in the chat. So we need something new, and that's where I'm trying to bring my contribution. So yeah, one day I went to the US, I sat with Bill Inman, we were discussing about star schemas, snowflakes, a lot of things. And I basically needed Bill Inman to support me because he's an important name. And this way I would be able to have more people paying attention to my ideas and hopefully questioning my idea. I'm here to be questioned. I don't manage it during this hour, but everybody can add me on LinkedIn and say, I like your presentation, but I disagree with this and this. Please do it. I'm not here to tell you a new truth. I'm here to be questioned because because the earlier I am aware of a problem, the better I can address it. So if you are skeptical, please share it with me. So we brought together this unified star schema. So you have to see this book, of course, as an extension of Kimball's approach, because there are many things that dimensional modeling, in my opinion, doesn't address enough well. So it delivers something, but I'm missing a lot from the dimensional modeling, the connection between fact tables. Also because now I am working on a personal project on Kraken, this platform of cryptocurrencies, and it's very common to have an order that you do on a transaction. You do it on the platform. Sorry, I need to drink. And when you create an order, you may have multiple transactions associated to that order. And each transaction has 2 rows of ledger. So it's a chain of fact tables. And that's so common. And with the dimensional modeling, that cannot be addressed because in dimensional modeling, the facts are explored through dimensions, but then they are silos. I need something more. I need a discipline where everything is potentially connected with everything. This is what the Unified Star-Schema is all about. So this adventure works that I showed you earlier. You guys said you cannot put it all in one table, and I agree. Can we fit this entire database into a star schema? I probably turn on the light. Can we fit this database into a star schema? Probably yes. Well, otherwise, why am I here? So yes, we can. This is AdventureWorks organized as a unified star schema. So all the tables that you see here, now they are here. In the middle, there is the bridge, or I don't know if we have Cindy today in the call. I hope we have her. Cindy, who is actually an organizer of the Data Vault Alliance, she was very kind to help me with this book. And also she said, why do you call it bridge? You should call it the Puppini Bridge. And I said, come on, but no one will like this name. And the email was addressed to me and to Bill Inman. And then Bill Inman said, yes, I agree, you should call it the Puppini Bridge. And I said, okay, fine, but you're 2 votes against 1, so let's call it the Puppini Bridge. So basically this table that is in the middle is basically the heart of a star schema where you do not have anymore the limitation of facts and dimensions. Basically, there is no distinction. A table is just a table. Numbers can be in any table. Measures, like numbers that you use for aggregation, you show in your reports, they can be in any table. They can be here, 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 here. They can be anywhere. Okay, so I owe you a live demo. Let me drink a glass, and probably if you guys have some doubt, you can write it in the chat. This looks like a tabular model. By tabular model, do you mean the one of Microsoft, like Microsoft Tabular? that would be interesting to hear from you. It's a question, so please, yes, and then click. Yeah, the thing is, all the solutions that when I'm showing this, people are saying it's similar to something, but then when I'm going there to really investigate if it is really a multi-factor solution, they say yes, but then it turns out it's rather no. So this is multi-fact. Now I don't think I can, yeah, I can zoom. This is a multi-fact solution. So you have, but you have here the sales, you have here the purchases somewhere, the purchases from the supplier, and you have the production. So you have really multiple fact tables. And to my knowledge, today, there are not many solutions that are able to put these tables all connected together, all in one star schema. I would be very surprised. So they are all here. Okay, so that was the last slide, but I owe you an explanation. So how do I do this unified star schema? I want to show you some photos that I took yesterday that probably are better than 1,000 words. These are 2 cans of beer. I guess you know that. Imagine that these are 2 tables, okay? This is a join, okay? So 2 tables next to each other. How would you do a union instead of a join? How would you put the 2 cans? Again, I'm checking the chat. Yeah, and of course I have questions from Greg. He's asking if the solution scales, and I need to address that. If I manage it today, I hope I will. We are arriving until the hour. I'm afraid we will go a bit beyond because we have more time here at the other events. I will not have much time to go beyond. Here I do, so I want to take advantage of that. But this is a join. Okay, these are 2 tables. This is a join of a tables. Can anyone write in the chat how is the union of 2 tables? Stack the cans. Thanks, Redrick. On top of each other. Exactly. So this is the unified star schema, basically. The key concept is that the unified star schema uses, first of all, a union. So it puts the tables above each other or underneath each other, stacked, exactly. Why does that make a difference? Well, because when you, if you look at 2 cans that are identical, it's easy. You do this join, it's fine. But the problem is this one. So when you have a table of sales and a table of products, for example, they have, imagine that these are 1,000 rows and these are just 30 rows. So they are not told the same because this one has more rows. Okay, so how do you put these 2 cans together? Well, either you compress one or you extend the other. So in this case, and I think I have no more slides. Yeah, one more. So in this case, this is your products table and your product name will be repeated multiple times. No problem with that. Actually, can you concatenate any number of tables, not just 2? Yes. So Jose Diaz is asking if I can concatenate any number of tables. Well, in this example, I have concatenated here 71 tables. So you see them here, but they all have a stage inside this bridge. So I have concatenated 71 stages all in one table. So that's the idea. You concatenate the stages. What is a stage? The stage is basically only the keys of the table. So basically you leave the table where it belongs. So if you have a table called sales, you leave it there, but also you put a stage of sales here in the bridge. And because you guys are asking, so it's important to address this question about the performance. So if a table, okay, let me read it. Does the solution scale? I have 4 billion rows in one table. A bridge will have many billion rows. Yeah, so the bridge will become very big. because this is a typical question that I receive every time, I want to address at least this question. Yes, so this table bridge has a number of rows which is equal to the sum of the rows of all these tables. So yes, it is big. Please be aware that I'm coming from the world of Qlik. In Qlik, data sets are never too big, and I am aware of this limitation. I admit it, this is a limitation that I have. I always worked on data sets which fit into memory. So it's usually not a problem. But I'm aware that we are in the world of big data and there are large data sets, and the solution would not work because a table that has billions and billions all in one table is very difficult to partition. It's very difficult to organize it in different nodes. So I understand that. That's why I want to show you the solution of the Unified Star-Schema, how it really is. I open this file and I show you how things are. So order details, shipments, these are the tables that you have seen earlier, but they all have one additional column called underscore key underscore name of the table. This is everywhere, and it's just a naming convention, but it has a few reasons for being there. Then the bridge is actually organized in many tables. So this table, for example, is order details underscore PB. PB stands for Puppini bridge. So if you look, orders has 4 rows, okay? Then the orders PB, it has 4 rows. If you look at shipments, shipments has 5 rows. So shipments underscore PB has 5 rows. So basically these tables, they have all the keys and they are independent. So you can, when you are making your solution, you can pick the portions of Puppini bridge that are interesting to you and disregards the others. This way, your solution has a challenge of performance that is very similar to the challenge of performance that you have today with your traditional star schemas. Because if you have 4 billion rows in a star schema, I guess in any case you want to work on aggregates, or somehow you need to address it somewhere. In the moment when you are solving the solution with your star schema and it fits in your reports, then I guarantee that also the Unified Star-Schema will have a performance that will be very similar. I guarantee. I haven't tried it, but I have the feeling that it will be like that. So I can do quickly a demo. I guess you guys are curious. Yes, this is more about concatenation. Yeah, who is writing concatenation? Joseph Chen. I don't know, the word concatenation has multiple meanings. If you are coming from Qlik, yes. USS is more from concatenation. Actually, it was, that's from Qlik that I had the idea. You can see it as a factless fact. Yes, these are all comments that are correct. I just go to the point and I open one more. So this is the final demo, the most important, because I'm showing you the baby. So I have 2 solutions, unique bridge or with the PB option, with the Puppini bridge tables option. But actually this has everything. So I go directly to this one. So you see how it works. So if your data fits everything, like it's not too big, you can start with the bridge. But because you guys want to immediately address the challenge of performance, I understand that. So we can do it. That's an example with portions of the bridge. Imagine that you want a report about sales, so about the orders. So what you do, you just take this, and then you want to simply see the clients. So you drag it here, not like this, because this would be like a can next to the other. We want to pile up. So you drag it here, union. And then you take the, what was that? I already forgot. It was the edit union. It was the clients. So I take now the products PB, I drag it here. Here you go. And imagine if you're not interested in anything else, you just keep this 3 stages. But now, because I want to show you the full thing, I also put the stage of the shipments. So as you see, I drag it here and they automatically adjust. Why do they adjust? Because there is a naming convention. So Tableau by default is piling up the columns that have the same name. That's the whole point of having a naming convention. So now basically I have manually built a Puppini bridge with 4 stages. Now that I've done this, I take the flesh. This is only a bone, like it's the backbone. There's no, well, there are numbers. I need to explain that, but I cannot do it during this phone call, during this presentation. So this is the backbone. And now I put the flesh. So the information about the product name and everything. So if I want the products, I double click and I don't need to do anything else because Tableau already knows that it joins by products and products. These are actually not joins, these are relationships, which are the ones that are keeping the numbers correct that we have seen earlier. And then I want to see the shipments. I double click and sorry, I pulled the wrong one because it happens. Shipments is this one, double click, and it's automatically connecting. And then I want the order details, double click, and it's automatically connecting. And then I want what is missing, the product, so the clients. So I double click on clients and it's automatically connecting. So imagine in your organization, you have junior developers that are in charge of making fancy charts, fancy data visualizations. So you can give to them a unified star schema and they just pick what the client needs, the end user needs. So they just drag and drop. They don't need to care anymore about anything because all the connections are happening through the bridge, through the Puppini bridge, and they are all always automatic. So then you go to your sheet and you start to make your report. So you can put, for example, we can do the product name, for example, and then we can put the order detail quantity and then the shipment quantity. And then you can create a look at the totals. So totals are important. And these are the numbers that are correct. But you can also now change your point of view. So you can say, for example, I want to see it now by client name. So I go to clients, client name, I drag it here, and I have immediately the same totals, but organized by client. So this is behaving now like a pivot table of Excel, except that it's going through 4 tables and that are also more than one fact table. So you can have the same thing, and I can even show it to you as a closing of this presentation with AdventureWorks. So imagine that you can open AdventureWorks and you can have in your data model, as you have seen earlier, you have all these tables, and this is live. It's not like an image that I built. These are real tables, and you can in your front end, in your presentation layer, you can drag and drop columns as if they were all from one large table, except that they are from 71 tables, but they are all compatible. There are no duplicates because when you pile up the cans like that, you don't have duplicates. That's the magic of the Unified Star-Schema. So you will never have duplicates of numbers, and all the connections, interconnections between fact tables, now they are possible. They exist in the OLTP, and because the dimensional modeling of Kimbo does not address them, I said, okay, let's create a new extension of Kimbo where you can have a relationship between 2 fact tables, which have the foreign key and primary key, and they will not create duplicates. All right, so I believe we are done, and I go back to the slides, and these are the chapters. So in the book, the first part is written by Bill Linmon. It's more about the history of data warehouse, and the second part is about the Unified Star-Schema. So I give, first of all, an introduction, and then I address the problem of loss of data, and then I talk about the fun trap, which is the one that we had in our example. Then I'm talking about the chasm trap, and it's many pages about the chasm trap, and I talk about the multifact queries because they are the challenge. And I talk about the loops. That's very important because when you have a referential, when you have a loop It's called, doesn't come to my mind now. So tables form a loop. That's normally a problem, and the Unified Star-Schema solves that problem. It's called circular reference. And then non-conform granularities is very important message. For Kimbo, it's important that the dimensions are conformed. For me, it is not important. I do not need that. If someone has conformed the dimensions, it's great because it's an additional work, but please leave me the original. So if you have conformed the customers from the CRM and your system, and you had to merge 3 customers to conform, fine, but leave me also the 3 originals because I'm using that. I do not need conform dimensions. That's basically it. I guess I am ready to be attacked by everyone, by all the skepticism. I'm here, I'm ready, and the word is to you guys.
Thanks, Francesco. I think Francesco wanted to know about if you have had, he wanted to share a poll, so I'm going to share that with you guys. And that's something, if you guys can answer the poll.
Oh yeah, I forgot about that.
That's one. I'll also address some of the questions that I see, because some of the people are asking, can this be virtualized, or does it have to be persistent?
You know, the answer to this question is, let's work together and let's find out. My perception is that the Puppini bridge must be persistent and all the tables around can be virtualized. That's my intuition. But again, my weak point is I've never worked on data sets that were so challenging that you need to virtualize. I should try it.
Another one is, does this, you know how the data vault keeps everything, and then we have bits and bridges to get the data out, and we create a virtualized dimensions and stuff with that. Does this eliminate our need for bits and bridges? That's another question that comes up.
No, it does not. No. Yeah, one thing I should have made clear, this entire solution is downstream of the data vault. The work that Dan Lindstedt has done is immense, and I would have never been able to do a work like this. So he has created a system of record that is resilient to changes of data source, and it's able to address the needs of the constraints of auditing, and it's able to address other things that can happen in institutional or governmental companies. I've never done anything like that. I would not touch anything of data vault. All I'm saying is, once the data vault is preparing the data for the end users, beside the business vault, which is the word that didn't come to my mind earlier, beside the business vault, instead of doing a dimensional modeling, you should consider doing downstream of the data vault, not a dimensional modeling, but this extension of the dimensional modeling. So it's like satellites, bits and bridges, all these things, they have to exist for reasons that I don't even discuss. But downstream of that, instead of just one star schema, I suggest you can do a unified star schema.
There's another question. It says, how do you ensure that you don't have column name collisions across so many tables?
Very good question, very good question. It's part of the methodology. So in the book, I'm addressing that. I'm making in the book an example that if you have a zip code, you have a table customers, and you have a column called zip code, and then you have a table suppliers, and you have a column called zip code. These names are context dependent. So you understand what they are because you know that they are in that table. So there is, thanks for asking this question, there is a need of creating a data catalog. A data catalog is needed. But it's needed in any case. I mean, in a company, when you are integrating data and you don't want to have silos, means that you want everything available, you should behave as if you, every column name, you write it down on a piece of paper, you put it inside a hat, you pick any name, and you must know what it means. So if you had columns called zip code, and all that columns are only understandable by the context, context. In any case, you need to change that name. You need to give to every column of the flash of the tables that you connect. You need to verify. You need to have a place where you have a data catalog. You need to verify the names that exist, and you need to manually make this exercise. It's painful, but it's needed for my methodology and for every other methodology where you want to have any hope to achieve self-service business intelligence.
Another question is, does this mean that the aggregate and the drill down, they can sit in a single bridge table?
I like this question. Can you read it again?
It says, so aggregate and drill down can sit in a single bridge table.
Who asked that question?
Adarsh Vanjari.
That's spot on. That's the core concept of the Unified Star-Schema. So you have both the aggregation and the drill down. Yeah, that's exactly what the Unified Star-Schema is.
Well, this is more of a request by another Francesco. Talking about performance, I would like to see the USS model applied to a blockchain data structure as the one you quoted before, the cryptocurrency app.
Francesco, I'm going to Bologna this summer if God wants. So we will meet and we will talk about that. I would love it. I remember that you're an expert of blockchain, and we should definitely do this exercise together. But definitely, I believe that with this approach, life is easier because blockchain, even the name blockchain suggests the concept of a chain, and the Unified Star-Schema pays a lot of attention to the fact that there are chains of things that need to be made easier for the end users. That's why there is a concept of the derived key, where basically you don't need to care about the chain anymore, because downstream of it, it is addressed inside the Puppini bridge. It's a funny thing about words, because blockchain has another meaning. I know that, but somehow I like to think that it's correlated. Let's do this exercise. I'm coming in July to Bologna.
Okay, so there's a comment, DV link, it maintains the same schema. The bridge here, the schema would change as tables are being added.
Yes, yes. So again, a very, very good point. The thing is that in any case, when you have a schema change, you need to address it. So if a column is renamed, for example, it's a problem that's breaking. This solution is breaking the Kimbo solution, is breaking everything. And if columns are added, yes, if you are using the traditional Kimbo approach, you don't have a problem, because what you do, if you have new columns or new tables, you create a new StarSchema. In this case, it's more challenging because you need to work on the integration with all the rest. So imagine that you have a Unified Star-Schema where you have a reference to a supplier, but the supplier table was never included. It was somehow supplier 1, 2, and 3. And then suddenly a supplier table appears. So not only you add the supplier table to your schema, but then you need to make sure that all these other tables which had a foreign key pointing to that supplier that was not available, now they should point to it. So every time something is added to your data source, you wanna do an exercise of understanding how this integrates with all the rest. The good news is that the adding is never a problem. So there is conceptually no limitation in the complexity. So in many reports of business intelligence, for example, you cannot add too many things, because when you keep adding things, they break. While here, everything is linear, because everything is piled up. There's never a risk to create a conflict. When you're adding, you're never creating a conflict. And yes, you need to work making sure that things are integrated. Yes.
So another question, which I think you've already answered, is shouldn't this be done in views in the database instead of in the BI tool? And another person has commented that it's not likely to handle volume.
Yeah, exactly. So when it comes to views, yeah, the architecture that you choose is up to you. The important is that the bridge must be there. Most likely it needs to be populated persistently, and it needs to have everything prepared to be joined or viewed. The thing is that in any case, the BI tools are, in most cases, they are doing their local copy of the data. That's happening. So the BI tools, they're installed on servers and they make a query. And when they retrieve the data from the query, they have their local copy. That's already happening now. So by not joining inside the database in the data warehouse, I basically skip one step because every piece of data is stored on disk only once. So my surname, Puppini, if I am a client, is only appearing in one cell of one table, so I guess called clients, and it's only appearing there. There is no denormalization, so it will not appear in other pieces of queries that are of materialized views that are here and there. So my recommendation is every piece of information needs to be stored on disk only once. Everything must be ready to be joined, and the join can happen with a view that is written like the code is written in the data warehouse and it's resolved by the data warehouse, or it can be happening inside the your BI tool. So it all depends on the architecture that you have. The bottom line is that everything must be easier and it must have zero redundancy on disk. That's one of the achievements that you have with the Unified Star-Schema.
So Noel is asking, can you show the example with the shipments and returns you showed at the start, but using the Puppini bridge? I think you already did that, didn't you?
Yeah, that's I did, but I was going a bit fast. That's always the problem of not having 10 hours. So this one is, yeah, it's basically this one. But she has a point. I don't heard who it was. Wanted to see the bridge. So here it is, and that's a very fair question to ask. So the bridge always have the first column is called stage. And you remember that we had order details with 4 rows. Here they are. So these are the keys with the standard naming, underscore, key underscore, and name of the table. So because order details doesn't have a foreign key to shipments, it's empty, you see. And some numbers are here. This is a technique to avoid duplicates in the cases when your BI tool is not capable of in-memory association or relationship, as they call it in Tableau. But this I will address in another call or workshop or whatever. This is interesting. The stage of shipments. It has 5 rows, exactly like shipments table has 5 rows, and it's all populated. So this is what I call a lion. Is the king of the forest. The king of the jungle. So it is basically a table that is hunting all the other tables, but it's not hunted by any other table. So in this data set, there is not a table that contains the foreign key that points to this one. So that's why I call it the lion. While a gazelle is this one, clients. It doesn't point to any other table. So it's totally just a prey. It's not a hunter, it's just a prey. But it's important to have this table because in this case there is a measure that you want to put here so it doesn't have any duplicates. And also in the case of products is also prey, but you see there is product number 4, which is only appearing here because for some reason nobody wants to buy product number 4. So by putting it here, a stage dedicated to product, even if the stage itself has no foreign keys populated, it's still useful to have it because it's so-called full outer join effect. So basically, even if in your query you're creating left joins against the Puppini bridge, in reality, because there is a union, so the cans are piled up, then this product number 4, it appears as it would appear in a full outer join, except that this is a left join, and this is happening because we have created a stage also for products. And so on. Yeah, this is the Puppini bridge for this exercise.
The next question is how to model a Puppini bridge in a big data ecosystem like Cloudera, for instance.
Yeah. Okay, so there's one thing you need to know. In any case, when data is in a JSON format, turn it as you want, even regardless of the Puppini bridge, you always need to make an exercise of turning the JSON files back into a tabular format. So forget about the Puppini bridge. I ask you, how would you do it with Cloudera if you had to create a Kimbo StarSchema and you have a table called the orders, which embeds in the JSON the information about the order details? Well, you need to make an exercise working on the JSON and turning the JSON sub arrays and sub dictionaries, you have to organize them in multiple data frames. That's the important part. So no one says that one JSON becomes one data frame. One JSON can be multiple data frames. So basically what you do, you return the JSONs into tabular format. And when it is in tabular format, then you apply it as if it was a transactional database, relational database.
Okay, so the next one is the SQL behind the view would need to include all columns. This can be a challenge. Another challenge is that view would have hard time to import data in terms of performance.
Sure. Okay, all columns, I'm not sure. I mean, it depends how you write the view. You don't write the view select star. So the nice thing of this is that if you store it, if you store all the components independently, then you have the freedom to take only 2 stages instead of 71 stages. And you have the freedom of writing in your view only the columns that are interesting to you. You don't need the full bridge. You just take whatever in the bridge is needed. Typically, you take from the bridge all the columns that exist, and they are not all the columns that exist. So imagine, it was a tricky phrase, so I'll explain it better. Imagine here, I have 71 tables, okay? So the bridge, if you watch it inside, I guess it has 71 key columns. This is the full bridge, but as we said earlier, you can play with the portions. So you can take only a few stages, and those stages, they will not have 71 columns. They will have 3, 5, 7. So the trick is how to do the union, because the union in SQL is painful, but in Java and in Python and in R, it's much easier because it dynamically piles up the columns that are identical, that have identical name. And for this reason, you just take all the tables that are underscore PB, you just combine them together automatically, whatever number of columns they have, and then you left join to them the flash. And the flash, I mean, you pick what you want. If you have a table sales that has 2,000 columns and you only need 15 of them in your query of the view, you will only pick the 15 columns that you need. So that's a normal thing that you would do also in the normal world.
So Knowles has said, so the Puppini bridge is exposing the subject matter metadata in the data, readily qualifying the joins and thus providing the flexibility and correct reporting.
Is that a question or?
It looks like a comment.
Yeah, so hi Knowles, nice to hear from you. I guess that's more delicate. So from you, of course, I would expect this type of more elaborated thoughts, and I would be happy to discuss it whenever we have an occasion, which of course cannot be in Vermont because we are not going to meet there this year. And let's not forget to talk about that. But yes, I would be very happy to be in touch with you also.
Another question is, so this is a redesigned third normal form?
Well, no, because this is a third normal form. No, this is not. This is not a third normal form. That's not what I wanted to show. So this is a third normal form, and it is given. Data is given. Data means given. So I receive this. This is in third normal form. So what I do, I turn this into a one single star schema. So it's totally one star schema. It's not a third normal form, but I am leveraging from the third normal form all the existing foreign keys, all of them. And that's a very important statement, because you would never be able to use all these lines that you have here, because they are more than you can have. So if you have 71 tables, the maximum number of lines that you can have in a join are 70. So n minus 1. And instead, in the third normal form, you have more relationships. So here there are circular references here. There are loops. So I am taking all the information that is in the third normal form, and that is not in the dimensional modeling. That's why earlier the girl, I forgot her name, she said we are mixing up the two things. Yes, we are. because I'm questioning the way how the dimensional modeling is working today. That's why I need to go back to the third normal form, where I trust that all the information is there, because it's operational. So it has to be there, because when you are creating a shipment in an application, that shipment must have the ID of your order of your order detail. So the third normal form to me is the ideal starting point, and I'm leveraging from it everything that I'm able to leverage, because it's every line here is a foreign key pointing to a primary key. I don't want to lose that. And the third normal form is the place where I find all the information that I need.
So I think the next question is something that you may like, because it falls in line with our poll. It's a comment. USS may not handle changing dimensions. Using product as an example, the same product ID needs different keys if the product has different names at different times.
Yeah.
If I'll also add the context of the poll here. I've shared the results. I don't know if you can see it.
Yeah, we can see it. So 55% had several times the requirement. Okay, you have to know, guys, that this was from a chat that I had with Sanjay a couple of days ago, and I told him, no, users don't need this, but apparently they do. My personal experience is that in my team, once we were doing so much effort to create slowly changing dimensions to the users, and the users said, we never asked for that. We just receive it because you were insisting so much to give it to us, and we had to use it. But okay, if there are projects where actually they really need it, it's fine. So to address your question, the Unified Star-Schema is an extension of the dimensional modeling. Whatever the dimensional modeling can do, the Unified Star-Schema can do. Now I turn back the question to you. Can the dimensional modeling handle this slowly changing dimensions? Well, probably yes, with some coding. Because when you are preparing a StarSchema where you give a sales table and you give a client table in a format of a type 2 slowly changing dimension, that client ID is repeated multiple times with date ranges. I ask you, how do you join it to the sales table in a traditional Kimbo approach? There must be some way. So probably you are selecting where end date equals null, or you are creating a join with the between, but that join is written ad hoc. So you need to have someone that is writing code ad hoc. If you can do it in Kimbo, you can do it in the Unified Star-Schema, because everything that is in Kimbo is also in the Unified Star-Schema. So I'm happy to be contacted if I didn't answer the question enough in detail, because slowly changing dimensions are a delicate topic, and my challenge is there's nothing that Kimbo can do and the Unified Star-Schema cannot do.
Another question. Okay, so this is not a question, just a comment. So one of the observations, the Unified Star-Schema is a technical solution, right? It's not exposed to the user. It hides behind the scenes.
Better. Yeah, better not. Of course, it must be done by some data expert. Yeah.
Okay, I think we are done with the questions. I don't think there's any more questions. You had some special offers to make to the audience.
Yeah.
Which, you can do that.
I have a special offer. No, because I will be speaker at the Worldwide Data Vault Consortium on the 17th, 21st of May. I have received from you a promo code, and I'm happy to share it in this call and also with my network on LinkedIn. So if you guys want to come to the conference, which of course this year will not be in Vermont, it will be online. You can register for the event with the promo code. Let me unshare my screen because it's nicer to. Oh, I'm not sharing. I'm still sharing my cons. So stop share. Okay. Yes, so you can register for the event in Vermont, which is online, with the promo code Puppini21, like 21, like this year of pandemic. And yeah, with the code Puppini1, you will have a discount of 20%.
20%, and this is it's something we did for Francesco, because Francesco's publisher did the same thing with us. I'll be sharing that with everybody in an email trail. I think they have shared the same code where you can get 30% off his book if you buy it from the publisher. So I will be sharing that link with you in case you're interested in getting this book. So that I'll send out in an email probably sometime tomorrow. So that's pretty much it, and I think we should be good. Thank you so much for your time, Francesco. Really, it was good. I'm sure everybody here
Thanks to
enjoyed
everyone.
it.
So we had the 53 people who were doing it until the end. Thank you for being here until the end. It's a long topic. It's a tough topic. It has a lot of questions. I renew the message, guys. Please add me on LinkedIn. I'm happy to discuss. Some of the people in this call know it very well. I'm happy to listen to criticism. And yes, if you want to buy the book, you can use the code on the website. Actually, we don't have it ready here to show on the website of the publisher. So you can write to me, but basically with this Puppini 21 code, you can have even 30% discount on the book. So if you're interested, basically write to me and I will arrange that for you.
All right. Thanks again,
Finito.
Francesco. All right. Take care.
Bye-bye, guys.
Yeah. So everybody is giving you some nice comments. I think they enjoyed this.
I'm trying to save the comments somehow. You know what? Before you close the call, I copy paste all these comments and I save them on a Word file. So I will read them. They could have done a button export chat.